Hello everyone, it's me again, Professor Tori. As always, my purpose for today is to give explanation and to make sure you understand more regarding the topic mean deviation, variance, and standard deviation. Enjoy the video. In the previous lesson, we have learned about measure of central tendency, and now we're going to learn about measure of dispersion. These two make the base of the larger topic called statistics. So if you aspire to be a statistician, quantity surveyor, or even an engineer, among other professions, then you need to understand and learn these concepts. We are going to learn about mean deviation, variance, and standard deviation. Now, this is the graph that I used to depict the statistics of heights of Malaysian adult men. So if for whatever odd reason I want to add the heights of the dwarfs from the Middle Earth, you know, if you remember Lord of the Rings, then the bell curve will probably look like this. The curve has become more spread, or in statistical language, we call it that the curve has become more dispersed. This is to give you a graphical representation of the measure of dispersion. I'm going to use the exact same scenarios as the previous lesson, which is the height of football players. And this time, I'm going to compare the mean deviation, variance, and standard deviation in between these two scenarios. So stay tuned, sila duduk, jangan lari. On the screen right now is the height of Malaysian state football players before we import 3 foreign football players. And they are already ordered in incremental values. And these are formula for mean deviation and variance. And notice that I have used a symbol sigma instead of S. Well, there is one important difference between sigma and S. Sigma normally is used for population data, while S is being used for sample data. And because my example will be based on population data, so I'll be using sigma instead of S. The first step in finding the mean deviation and variance is to calculate the mean. But we have already done this in the previous lesson. The value is 165.9 cm. And it's very helpful if we can sum up or put the data into a table like this. The first row is the raw data of the heights of the football players, and they are denoted by variable x. And the second row is x bar. X bar is the mean that we have calculated previously, which is 165.9. So we populate the whole row on that second row. The second step is to perform x minus x bar, and we got this. Intuitively, this row represents how much each data point deviates from the mean. So naturally, the answer will become negative and positive numbers, like here. If we total them up, it should give you a sum of 0. Now the next step is to perform modulus of this deviation. And this is just to turn negative numbers to become positive. And we require this data so that we can calculate the mean deviation. The fourth step is to square all the deviations, and as such it becomes a positive number. And we require this data so that we can calculate the variance and standard deviation. The fifth step is to sum up the fourth row, and that will give us 35.9. And this is just the total of the deviation. Because the number of data point is 15, then n is equal to 15. Dividing 35.9 by 15 will give us 2.39. So this is the official figure for the mean deviation. And the last step is to sum up the fifth row, and that will give us 134.95. And because the data point is 15, then dividing 134.95 by 15 gives us 9. And 9 is the variance. And let's update our table. And now the standard deviation. Once we have already found out the variance, finding out the standard deviation is a no-brainer. This is the formula for sigma. Sigma stands for standard deviation. And it's just the square root of a variance, or square root of sigma squared. Since the variance is 9, then standard deviation is equal to 3. And we update the data in the table here, and we'll compare those figures in the next scenario. The team manager imported 3 tall players, and the new data set is shown on the screen here. Now we have the total of 18 players. As we have learned previously, the addition of 3 tall players has changed the mean drastically. The new mean is now 170.8 cm. So let's populate the table. I've also populated the deviation from the mean, the modulus, and the square of those deviations. So to calculate the new mean deviation, just sum up all the modulus of deviation and then divide that by 18, and that will give us 8.17. While for the variance, we sum up all the squares of the deviation and divide it by 18, that will give us 130.3. And then the standard deviation is just a square root of that, and that becomes 11.4. And we update the table as on the top right over there. As you can notice, the mean deviation, variance and standard deviation are quite low before we add the 3 tall players, but after adding them, the mean deviation, variance and standard deviation has increased tremendously. And that's what happened when we add some extreme data or out of norm data out of the typical range. So now you have learned on how to calculate mean deviation, variance and standard deviation. I hope you have learned what these 3 numbers represent in the scenarios that I have presented. Thank you for your time and interest. Make sure you watch another video so that you can learn more knowledge in mathematics. See you again. Bye-bye.